Hello and welcome to the second in our VEXcode VR tutorials. Today we're going to be looking purely at the drivetrain blocks. So in the toolbox, the drivetrain blocks are under the drivetrain heading and are all of these blue blocks here. And the drivetrain are specifically related to the movement of the robot, so the way that it kind of navigates around the field. So let's start by opening a playground. I'm just going to open the grid map, which is the kind of basic empty playground, and then we'll start working through the commands and seeing how they work. So the first thing you'll notice is that for the drive forward you have two different options here. You have one that's just drive forwards and one that is drive forward 4 and then it defaults to 200 millimeters. Now the difference between these two blocks is if I use the drive forward command that has no separate parameter, just drive forward, the robot will continue to drive until I tell it to do something else. So in the case of a very simple program like that, if I execute it, the robot will drive forwards and it will never stop. And at some point it's going to crash into the wall at the end of the field. And so it's still trying to drive, even though it's reached the end, and in fact it's going to flip over there because it's driven up the wall at the end of the field. So until I tell it to do something else, it will just continue to drive forwards. This command with a parameter, drive forward for 200 millimeters, I can enter whatever parameter I like here. So I'm going to say 1000 millimeters. This will specifically drive forward for 1000 millimeters for whatever I set this parameter to. So if I hit play there, you can see now this block is flashing, it's executing, and it drives forwards 1000 millimeters. Okay, and we have the same for the turn blocks as well. I suppose something else I should say about the drive forwards blocks is that both of these can be dropped down to also be reverse, so they're forwards or reverse. So the same can be said for our turn right and turn left block. So this one will just turn continually until I tell the robot to do something else. So it's just spinning on the spot there. Whereas if I use this version with a parameter, it'll be a very specific amount. So if I say 180 degrees and execute that, then the robot will just turn until it's facing the opposite direction. So 180 degree turn, and now it's facing the other way. So those are our drive forwards, reverse, turn right and turn left commands. Then we have turn to rotation and turn to heading. Now, these are slightly different to the turn right 90 degrees and turn left 90 degrees. The reason being that these are kind of fixed from a starting point of 0. So if you look here in the information box at the top of the playground, you can get, if that's not showing, you can just click on this little button here to make that show. We have heading 0 degrees, rotation 0 degrees. We're facing straight up the field. When I say turn right 90 degrees, or whatever number of degrees I want to turn left or right, that's adding it on to the existing position. So it's just 90 degrees from where I am currently. So let's use an example here. So if I just say turn right for 90 degrees and run that program, my robot turns right and is now facing 90 degrees to the right. If I run that same program again now, it'll just turn another 90 degrees. So now it's facing the opposite way. And if I run it again, another 90 degrees. And if I run it one more time, another 90. Okay, so the difference between that and turn to heading is the heading is always relative to the starting point, which is 0 degrees straight ahead of you. So it's got compass north, if you like, straight up the field is 0 degrees on the heading. So if I say turn to heading 90 degrees is compass east, so to the right. So if I say turn to heading 90 degrees, then I turn to 90 degrees, and you can see here now my heading is showing 90 degrees. If I stop that program and run it again, it won't add another 90 degrees because I'm already facing the heading of 90 degrees. So I'll run that again, nothing happens because I'm already facing compass heading 90 degrees. So what I'm going to do is go to 270 degrees, which will be compass west. So we've got 0 degrees straight ahead, 90 to the right, 180 down, 270 this way, and then back round to 0 again at the top. So if I say turn to 270 degrees, I'm going to run that, and the robot turns round to 270, but it hasn't turned 270 degrees, it actually turned 180 degrees to achieve that, to the compass heading 270 degrees. Okay, so turned heading is really useful because it's always relative to the same direction on the field, and so you don't need to keep track of the way that you're facing. The robot is doing that for you. The difference between turn to heading and turn to rotation is that turn to heading is, as I mentioned, a compass heading, so 0, 90, 180 south, 270 to the west, and then back round to 0 again at the north. Rotation is a cumulative value. So let's demonstrate that by using turn. So what I'm going to do is just create a little repeat loop. And we're going to turn right for 90 degrees, and then we're going to wait 1 second so that we actually see the robot stop. Let's get 2 seconds, so we've got a bit of a break in between, and then turn another 90 degrees. And what we're interested in is looking at these values here, heading and rotation, and what the difference is between them. So if I run this program now, and we do our first 90 degrees, and heading goes to 90, rotation goes to 90. The next one, heading 180, rotation 180, 270, 270, so we're tracking at the moment. Back to 0, 360 for rotation, back to 90 for heading because we're compass east, and you can see rotation is cumulative, it's just adding and adding and adding, and so each time I do one full rotation of the robot, I'm adding an additional 360 degrees to the rotation value. So rotation is different to heading in that heading resets at 0 every time you go past the north point, and rotation is cumulative, and that works both positive and negative. So if I was to stop this program now, and let's reset that actually, and if I change this to turn left for 90 degrees, now you'll see a big difference between heading and rotation, because heading, as I turn left 90 degrees, is going to go to 270, because 270 degrees on the compass is our sort of compass west, whereas rotation is going to go to minus 90 because we're starting at 0 and we're going to turn to the left, which is going to take 90 away from it. So let's run that and see that in action. So 270 here, but minus 90 there, and then minus 180, and so on. So this is keeping track of your sort of cumulative number of turns, and this is your compass heading. So let me just wait for my robot to get all the way back round to compass north. I'm going to stop it there, and you can see that the heading is 0, but the rotation is minus 720, so it's done a few rotations in that direction. If I now give it the instruction to say turn to rotation 0, this is not heading 0, this is rotation 0, it's going to have to undo that 720 degrees of rotation. So if I hit the play now, it's actually just reset itself to 0. Perhaps that's because I started that as a new program. So let's say, let's do a few turns. So we're turning to 180 degrees, and then to get back to 0, it's going to have to undo what it's the turn that it's just done. So if you had multiple rotations, so let's say we need to turn for 720, which is going to be a number of rotation, so 360, and we're coming up to 720. And then to undo that, it's going to have to get back to 0, it's going to have to undo itself, so unwind twice to get back there. So that's the difference between rotation and heading, and those two things are really useful when you're navigating mazes or trying to repeat certain instructions over and over again, because you don't need to worry about, well, how many turns have I already done, what way was I already facing. You can always use heading and rotation to get yourself back to known positions. Stop driving is very similar to the drive commands. If you issue that at any point, then the robot will just stop moving. Whatever it's doing, it will stop moving. For example, we could say drive forwards. And remember, I said this is like an infinitely drive forward until we tell it to do something else. So I could say drive forwards and wait for 2 seconds. So rather than driving forward for a given distance, which is what this block would do, I'm driving forwards for 2 seconds and then I'm going to stop. So if I execute that, we're driving forwards, we're waiting 2 seconds, and then we stop. And that will, regardless of which command you're using, if the robot is moving, the stop driving will stop it. The thing you need to take into account there is what's called blocking commands, and we'll come back to those in a moment. Okay, so the last blocks we want to look at are the set velocity. So there's set velocity for drive, so that's forwards and backwards velocity, so the speed that it goes forwards and backwards at, and turn velocity, that's the speed that the robot rotates at when it's turning. I think the default is 50. So if you haven't issued a velocity command at all in your program, I think those will both be set to 50. So let's see what difference it makes. So what we're going to do is set velocity to, let's say, 20%, and then drive forward for 200 millimeters. I'm going to copy those blocks, and at this point we'll set it to 40, 60, 80, and 100. So what the robot's going to do is drive forward one square at 20%, because each square on this grid is 200 millimeters. So one at 20%, one at 40%, and so on. So you can see it gradually increasing in speed. So there's the 20% speed, 40, 60, 80, and then the last one there at 100% speed. And then the same with the turn velocity. So if we were to set turn velocity to 20 and do a 90-degree turn to the right, so 20, 40, 60, 80, and 100% velocity turns. In fact, let's make these 180 degrees so we get a bit more time to see those. So every time it does 180 degree turn, it will increase the turn velocity by 20%. So there's a slow 20% turn. Sorry, 100. And then each 180 degrees we're speeding up. So now we're on 80% and 100%. So basically just the speed that your robot is rotating at. And the final thing is the set drive heading to 0 and set rotation to 0. So as I mentioned before, by default, the heading and rotation 0 is north up the field as the robot starts. At any point in your program, you can reset that so that a different bearing, a different direction becomes the 0. So for example, let me say I'm going to turn right at the start for 45 degrees, which is going to face me across to this corner of the field, and then I'll drive just to get us out into the field a bit so we can see things a bit clearer. And so my heading at this point as I'm driving across will be 45 degrees, but I can set that heading to 0, and then this, from this point on, rather than compass north being my 0, it's going to be compass northeast, so over to this corner. That will be 0. So then let's say, just to show the point, once we get there, we'll just wait a few seconds so we can see what's happening. And then we're going to turn left 45 degrees, so we're facing back up the field again, which will then be it won't be 0 when we're facing to the north anymore. And then if I, just to show the point, we'll say turn to heading 0 degrees, and that should face us back across to this corner, because that becomes our, here we are resetting that to 0. So here we go, let's see that program. So we're turning 45 degrees and driving forwards. And then when we get to there, we've set, this is now our 0. You can see heading is reset to 0. And now the robot's turning back to 0 degrees, which will be over here. There we go. So 0 degrees heading is over there. And this command does exactly the same for rotation. I didn't reset the rotation, so that is still, if I set my rotation back to 0, if I was to tell the robot then to head to rotation 0, 0 for the rotation is still north at the moment, because I have not reset that at any other point. So that just allows you to set any position on the field to your compass heading for 0, basically. Right, the other thing I want to mention is blocking functions and non-blocking functions. And what I mean by that is, on a blocking function, when those functions are executed, or when those commands are executed, the code won't move on to the next command until they're complete. So let's use an example here of the drive forward command, which is a blocking function, the drive forward 4 command. If I put this in here and I say I'm going to drive forward for 1500, and let's then say, just to show how this works, I'm going to use the pen command. So for the first demonstration, I'm going to put the pen down before that command and drive forward. So if I put the pen down and drive forward for 1500, the robot leaves a line behind it, because the pen went down and then it drove forward for 1500. Okay, if I reset that and swap these commands around, this is a blocking function, and so what will happen is the program will stick on this line of code until it's reached the 1500, until it's finished that code, and then it will move on to the next line, which means the pen doesn't go down at any point here until the robot starts. So until the robot finishes its journey. So here you can see this is flashing, it's driving forward 1500, and now the pen has gone down, because this was a blocking command. It stayed in this one. A non-blocking command is the drive forward command, because it doesn't have a parameter attached to it. So in this case, if I do this, the robot is leaving a line behind it, because this was issued, this non-blocking command was issued, and then this one was issued, and of course we never tell the robot to stop, so it doesn't. But you can see the difference between a blocking and a non-blocking command. So the blocking commands are all the ones that you see with this little white arrow facing out to the right at the end, and the white arrow allows you to change that command to "and don't wait." This makes it non-blocking. Now be careful how you use that and think about the logic of it before you use it, because if I was to, for example, we talked earlier about the stop driving command. So if I'd say I want to drive forward 1000 millimeters and use the stop driving here. Now this is in blocking mode at the moment. So when the program runs, this block will be executed continually until it's reached 1000, and then the stop will be issued. Well, that won't be any real different to having the program like this, because it was going to stop anyway after 1000. But let's see that in action. So this command is flashing because this is being executed at the moment, and it's got to 1000 and it's stopped. If I change this to and don't wait, it won't wait for this to finish before it moves on to the last command, which is stop driving. And hey presto, if I run that, the robot doesn't move at all because it didn't wait for this to finish and it told it to stop straight away. So you need to be careful about how you use that. Let's think of a practical application for it, because sometimes it's hard to think for a sort of a practical reason for why you would want to do that. Let's say I wanted to use the pen to draw a dotted line, and I wanted that dotted line to be 1500 millimeters long. So let's start this way. What I'm going to do is put the pen down, wait for, let's say, 0.3 seconds, raise the pen up, and then again wait for 0.3 seconds. So as the robot is driving along, the pen is going down, up, down, up, down, up. But when I'm in blocking mode, let's see that code in action. I run it, and at the moment the code is blocking on this line here, so it's just driving along until it reaches 1500. And now the pen is going up and down, which is not much use because the robot's not moving anymore. If I reset that and turn this into and don't wait, so this is no longer blocking, we're still going to issue the command to drive forward for 1500 millimeters, and we're not telling it to stop at any point, so it's going to carry on doing that. But the code won't wait here. It's going to set the robot on its way for 1500 millimeters and then carry on executing the rest of the code, which in this case is our repeat loop. So if I run this, we're driving forward for 1500, but we're also now going on to this loop, so drawing the dotted line, and then we've still got to 1500 and stopped. So that's the difference between the blocking and the non-blocking versions of those drivetrain commands. So they can be very useful. But when you're using the and don't wait, just remember that the command straight after it will be issued immediately. So things like, let's say, drive forward 1500 and then turn right 90 degrees. If I tell it to drive forward 1500 and don't wait, it's going to move straight on, and the next command is turn right 90 degrees. It's another drivetrain command, and it's going to override that. So if I run this, we never see the drive forward 1500 because we're not waiting for it to complete before we go on to the turn right 90 degrees. Whereas if I get rid of the blocking, turn it back into a blocking command, so then we drive forward 1500 and then turn right 90 degrees. So there we go, we can see we're stuck in this command until it's complete, and then we're stuck in this command until it's complete. So you just need to be careful about how you use those, but those are very useful commands. So I hope that's a useful introduction to the drivetrain. Next we'll be looking at the pen and magnet tools. In the next video it'll be the pen and magnet tools.